In this video, we're going to go through the steps needed to transition our analysis recast workflow to run on the REANA platform. So there's some instructions in the recast docs for doing this under the using recastable analyses. And if we go down to modifications needed on REANA, we're just going to go through and make these mods in this video. So the first thing is that we need to check that the short commit hash is included in the tag name for all of our GitLab images. So if we go into the packages and registries and container registry and click on our analysis image, we see that actually all of our images already contain this, this dash sequence of letters and numbers, where these letters and numbers are the short commit hash for our corresponding to the commit that produced this analysis image. And we can check that that's also the case for our event selection project. So yeah, we also already have the commit hash included. And the reason this is important is that the REANA server will only re-download a new container image if it's been updated. So if the image tag has been changed. So if we push new commits to the repository, it needs a new identifier to know that it needs to pull this updated image. Okay, so that's already been taken care of. Now, the next thing that we need to do is add REANA user as a member to our GitLab repos. So to do that, we go down to Members tab and search for REANA. And we have to add it with at minimum reporter status. So that's specified, oops, here. So we can invite REANA. And the reason that we have to do this is that REANA needs some level of access to our GitLab repository, or project rather, in order to have access to the container registry and be able to pull the images onto the recast cluster. So that's how we make sure that it'll have access. Okay, so that's good. Now, the next thing is we need to make a few changes to our workflow and steps.yaml spec files. And currently, the changes that we need to make are not compatible with running these spec files using the RECAST Atlas client. So we actually want to do that on a new branch that's different from the master branch that we would run the specs on using the RECAST Atlas client. So we'll call it REANA. And that's where we're going to make these updates to the workflow and steps.yaml files. Okay. So the updates to the workflow.yaml file are just that we have to specify that it needs to look for the steps.yaml in the specs directory, whereas the RECAST Atlas client just already assumes that that's where it's located. So we'll add that into the steps.yaml. Oh, sorry, workflow.yaml. My bad. And then in the steps.yaml file, we have to add a new resource, Kubernetes UID 500. And this is just to make sure that REANA will be able to read and write files in the container that's created from our analysis image, because that's the user ID that it expects to see. So I'll open the steps.yaml and add those to the resource field. And then we also have to replace the grid proxy resource with this Kerberos true if we want to use Kerberos authentication on REANA. So it just uses a different resource specification for that. So I'll copy that and replace the grid proxy with this Kerberos true. Okay, and then we can commit that update. The next thing that we need to do is modify any Docker files using Atlas analysis images as the base image, so that the Atlas user belongs to the root group, because by default Atlas only belongs to the wheel group. And it turns out that this is an issue in terms of accessing shared storage on the REANA cluster, because REANA assumes that the user will belong to the root group. So we just have to add this one line at the end of the Docker file that adds the Atlas user to the root group. And we only have to do that in our event selection project, because that's the only one that starts from an Atlas base image. Because remember, the stat analysis started from root conda base image. Oh, actually, it looks like I've already added that in. So, okay, it's been done. But this is the line that we would add in. Okay. And then lastly, we need to add this REANA.yaml file to the GitLab project that contains our recast specs. So this recast.yaml file, or REANA.yaml file, is very similar to the recast.yaml that we used to specify the input and output of our recast workflow for using the recast Atlas client, but it just has a slightly different syntax and organization. So this this box provides a comparison showing what the corresponding REANA.yaml file would look like for a sample recast.yaml file. So I'm going to go to the top level of the directory containing my spec files on the REANA branch and make a new file called REANA.yaml. And I'm just going to copy in the structure from this example in the recast docs, and then we can modify it to match our analysis. So if we go into our repo, we can open up the recast.yaml file and see what needs to be updated. So the first thing that we can update is the parameters. And this can just be copied directly from the recast.yaml file because the input parameters are going to be the same. And we just need to update this spacing a little bit. The directories can stay the same because we're still going to be looking in the specs directory for our workflow and steps.yaml file. And the type can also stay as Yadage because we're using the Yadage backend. And the yeah, we don't have to change this file because we're still using the workflow.yaml file in the specs directory. But we will need to update the workflow output. So that's going to be this p-value recast output that gets produced by the stat analysis. Okay, so that should be all of the changes that we need. And the next video is going to go through actually running the workflow on the REANA platform.